Hi guys, welcome to Research This, your research companion channel. It's a channel devoted towards my research streams, which I dive into everything and anything that I find interesting online. By all means, drop comments below if you'd like me to dive into particular areas of research that you want me to cover in the future. And please enjoy the content. I essentially research and then also add my commentary on top of it. So I hope you enjoy this. So, artificial intelligence in its broadest sense is intelligence exhibited by machines, particularly computer systems, as opposed to the natural intelligence of living beings. It is a field of research in computer science that develops and studies methods and software which enable machines to perceive their environment and uses learning and intelligence to take actions that maximize their chances of achieving defined goals. Such machines may be called AIs. Now, we're at this point in time where we've got AI hype everywhere. Like if you just take a look at all of the companies that are being funded by Y Combinator, a startup incubator in the United States, it's very clear that there are a lot of people that want to get in on this AI gold mine, so to speak. But at the same time, we're not at this kind of crazy period of euphoria like we were in the internet bubble of the 2000s. So it hasn't reached bubble worthiness yet, but it might have. Leave your comments below if you think that we've reached a bubble point or anything like that. But it is interesting to see how this AI revolution is taking place. AI technology is widely used throughout industry, government, and science. Some high-profile applications include advanced web search engines, Google Search, recommended systems used by YouTube, Amazon, and Netflix, interacting via human speech, Google Assistant, Siri, and Alexa, and autonomous vehicles such as Waymo, generative and creative tools such as ChatGPT and AI art, and superhuman play and analysis, and in strategy games such as chess and Go. However, many applications are not perceived as AI. This is because a lot of cutting-edge AI has filtered into general applications, often without being called AI once something becomes useful enough and common enough is not labeled AI enough. So, as you can see, it's clear that as soon as a tool that is AI becomes useful enough and integrated into a human being's life, we don't really define it as AI as much anymore. We kind of use it as like as a super tool. It's not necessarily the, Arnold Schwarzenegger version of the Terminator. It's nothing like that yet. So Alan Turing was the first person to conduct substantial research in the field that he called machine intelligence. Artificial intelligence was founded as an academic discipline in 1956. The field went through multiple cycles of optimism, followed by periods of disappointment and loss of funding, known as the AI winter. Funding and interest vastly increased after 2012, when deep learning surpassed all AI techniques, and after 2017 with the Transformer architecture. This led to the AI boom of the early 2020s, with companies, universities, and laboratories overwhelmingly based in the United States pioneering in significant advances in artificial intelligence. The growing use of artificial intelligence in the 21st century is influencing a social, societal and economic shift towards automation, data-driven decision-making, and integration of AI systems into various economic systems and areas of life. This impacts jobs, healthcare, government, industry, and education. This raises questions about the long-term effects, ethical implications, and risks of AI, prompting discussions about regulatory policies to ensure the safety and benefits of the technology. So as you can see, it is a societal uh, problem because it's such a advancement in technology. So we could see, and by the way, I'm just a layman. I'm your bro, just covering the topic. So I'm by no means like an academic expert in the field, but I'm just looking at it, and I think to myself that it's very much going to be an overall optimistic future for humanity with AI alongside us, because I don't believe that we're going to get to the situation where AI is going to become so powerful and human beings are going to be stupid enough to program it to make it so advanced that it actually, supersedes us in every way, shape, or form. And the person that does that must really hate humanity. They just really must do that. So I don't think there's enough cynics out there that would do that. I hope so. I hope not. Comment below if you think so. The various fields Very subfields of AI research are centered around particular goals and the use of particular tools. The traditional goals of AI research include reasoning, knowledge representation, planning, learning, natural language processing, perception, and support for robotics. General intelligence, the ability to complete any task performable by a human on at least an equal level, is among the field's long-term goals. To reach these goals, AI researchers have adapted and integrated a wide range of techniques, including search and mathematical optimization, formal logic, artificial neural networks, and methods based on statistics, operations research, and economics. AI also draws on psychology, linguistics, philosophy, and neuroscience and other fields. And it's really useful. I mean, anyone that's used ChatGPT today can see that it is an effective study tool, it's an effective research tool. It will get you somewhat of the way. I still think that human beings putting their feet to the ground, their foot to the grindstone, so to speak, will be able to get a longer way in a fuller understanding and comprehension of any topic that's presented in front of them, rather than taking the shortcut of just using ChatGPT to research everything. I mean, ChatGPT is a very good information synthesis tool, but it's not everything. So, goals. The general problem of simulating or creating intelligence has been broken into subproblems. These consist of particular traits or capabilities that researchers expect an intelligent system to display. The traits described below have received the most attention and cover the scope of AI research. So they are reasoning and problem solving. Early researchers developed algorithms that intimated step-by-step reasoning that humans use when they solve puzzles or make logical deductions. By the late 1980s and 1990s, methods were developed for dealing with uncertain or incomplete information, employing concepts from probability and economics. Many of these algorithms are insufficient for solving large reasoning problems because they experience a combinatorial explosion. They became exponentially slower as the problems grew larger. Even humans rarely use the step-by-step deduction that early AI research could model. They solve most of their problems using fast, intuitive judgments. Accurate and efficient reasoning is an unsolved problem. So there you go. So reasoning powers is something that's lacking so far, according to this Wikipedia article. I know, like, I'm not an academic necessarily, so I just take everything I say with like a grain of salt, because at the end of the day, I am a YouTuber and you're just watching this video and hopefully enjoying it along the way. But yeah, the reasoning skills of AI today is, as far as the posting of this video, not really up to the human comprehension or ability. Yeah. So knowledge representation and knowledge engineering allow AI programs to answer questions intelligently and make deductions about real-world facts. Formal knowledge representations are used in content-based indexing and retrieval, scene interpretation, clinical decision support, knowledge discovery, mining, interesting and actionable inferences from large databases, and other areas. A knowledge base is a body of knowledge represented in a form that can be used by a program. And ontology is a set of objects, relations, concepts, and properties used by a particular domain of knowledge. Knowledge bases need to represent things such as objects, properties, categories, and relations between objects, situations, events, states, and time, causes and effects, knowledge about knowledge, what we know about what other people know, default reasoning, things that humans assume are true until they are told differently will remain true even when other facts are changing, and many other aspects and domains of knowledge. Among the most difficult problems in knowledge representation are the breadth of common sense knowledge. A set of atomic facts that the average person knows is enormous. The sub-symbolic form of most common sense knowledge is much of what people know is not represented as facts or statements that they could express verbally. There is also difficulty of knowledge acquisition, the problem of obtaining knowledge for AI applications. So yeah, there you go. So common sense is not very common amongst everyone these days, but at the same time, uh, it is clear to see that like there are certain things that human beings know are true. Like for example, the stove is hot, but these are things that obviously we're taught at an early age in order to make sure that we navigate the world and don't harm ourselves. to any degree. Like for example, another common sense thing that everyone knows is you don't drive when you're drunk. It's like one of those things that we just take as common knowledge, but it's not always known by the AI applications that we're feeding the information to, for sure. So, planning and decision making. An agent is anything that perceives and takes actions in the world. A rational agent has goals or preferences and takes actions to make them happen. In automated planning, the agent has a specific goal. In automated decision making, the agent has preferences. There are some situations in which it would prefer to be in, and some situations it's trying to avoid. The decision-making agent assigns a number to each situation called the utility that measures how much the agent prefers it for each possible action. It can calculate the expected utility, the utility of all possible outcomes of the action weighted by the probability that the outcome will occur. It can then choose the action with the maximum expected utility. And then you've also got in classical planning, the agent knows exactly what the effect of an action will be. In most real world problems, however, the agent may not be certain about the situation they are in. It is unknown or unobservable, and it may not know for certain what will happen after each possible action. It is not deterministic. It must choose an action by making a probabilistic guess and then reassesses the situation to see if the action worked. So there you go. So this is a common thing that human beings do. We classically plan things. Like, for example, we might plan out how we're going to make tonight's meal, and you have a recipe, and you'll follow the recipe to the letter, and you'll follow it through to completion, and then you'll have the meal as the byproduct. But at the end of the day, this recipe came from a long period of time of human beings and self-discovery of different ingredients on how the recipe itself was created. So we had to plan it out after we discovered that certain spices were hot, etc., etc. You understand what I'm talking about. In some problems, the agent's preferences may be uncertain, especially if there are other agents of humans involved. These can be learned. With inverse reinforcement learning, or the agent can seek information to improve its preferences. Information value theory can be used to weigh the value of exploratory or experimental actions. The space of possible future actions and situations is typically interactably large, so the agents must take actions and evaluate situations while being uncertain what the outcome will be. A Markov decision process has a transition model that describes the probability that a particular action will change the state in a particular way and reward the function that supplies the utility of each state and the cost of each action. The policy associates a decision with each possible state. The policy can be calculated by iteration, be heuristic, or it can be learned. Then we've also got game theory, which describes rational behavior of multiple interacting agents and is used in AI programs to make decisions that involve other agents. So as you can see, there is a lot of planning and decision making involved in how we get the AI to function on its own and to plan and make decisions. So it's interesting to see that they use game theory, which is obviously a very well-known thing that is kind of described in a lot of pop culture these days. So it's very interesting. I'm sure I don't need to cover that, but yeah. So learning. Machine learning is the study of programs that can improve their performance on a given task automatically. It has been part of the AI from the beginning. There are several kinds of machine learning. Unsupervised learning analyzes the stream of data and finds patterns and makes predictions without any other guidance. Supervised learning requires a human to label input data first and comes into two main varieties. Classification, where a program must learn to predict what the category and the input belongs in, and regression, where the program must deduce a numeric function based on the numeric input. In reinforcement learning, the agent is rewarded for good responses and punished for bad ones. The agent learns to choose responses that are classified as good. Transfer learning is when the knowledge gained from one problem is applied to a new problem. Deep learning is the type of machine learning that runs inputs through a biologically inspired artificial neural network for these types of learning. So there you go. So biologically inspired. So based on our understanding of neuroscience, we go, okay, we want an artificial neural network. and we want to run inputs through it, and we want to see what we get out, and we want to see how it works. There's also been instances where we've had AIs behave in ways which suggest consciousness. I'm sure everyone in the comments below understands and has seen examples of this, and whether or not AI is sentient is still a heavily debated topic online. And there's a lot of people that are experts out there that might suggest that it is. I'm still a little bit skeptical on that one, but I could probably be, I had my mind changed for that. Anyway, so yeah. So computational learning theory can assess learners by computational complexity, by sample complexity, how much data is required, or by other notions of optimization. So natural language processing. So natural language processing, LNLP, allows programs to read, write, and communicate in human languages such as English. Specific problems include speech recognition, speech synthesis, machine translation, information extraction, information retrieval, and question answering. Early work based on Noam Chomsky's generative grammar and semantic networks had difficulty with word sense disambiguation, unless restricted to small domains called microworlds. Due to the common sense knowledge problem, Margaret Masterman believed that it was meaning and not grammar that was the key to the understanding languages, and that thesauruses and not dictionaries should be a basis of computational language structure. I don't know why that's spelled incorrectly. Please, Wikipedia, get on that. That should say thesaurus, thesauri, sorry, thesauri. Okay, the plural thesaurus. Okay, yeah. Modern deep learning techniques for NLP include word embedding, representing words typically as vectors encoding their meaning, transformers, a deep learning architecture using attention mechanism, and others. In 2019, generative pre-trained transformer, or GTP, language models began to generate coherent text. And by 2023, these models were able to get human-level scores on the bar exams, SAT tests, GRE tests, and many other real-world applications. So, as you can see, the advancements are palpable, and it's going to be interesting to see where it all goes. Perception. Machine perception is the ability to use inputs from sensors such as cameras, microphones, wireless signals, active LiDAR, sonar, radar, and tactile sensors to deduce aspects of the world. Computer vision is the ability to analyze visual input. The field includes speech recognition, image classification, facial recognition, object recognition, and robotic perception. Social intelligence. So, effective computing is an interdisciplinary umbrella that comprises systems and that recognize, interpret, process, or simulate human feeling, emotion, and mood. For example, some virtual assistants are programmed to speak conversationally or even to banter humorously. It makes them appear more sensitive to the emotional dynamics of human interaction or to otherwise facilitate human-to-computer interaction. However, this leads to give naive users an unrealistic conception of the intelligence of the existing computer agents. Moderate successes related to achieving computing include the textual sentiment analysis and more recently multimodal sentiment analysis, wherein AI classifies the effects displayed by a videotape subject. So yeah, a naive user might think that the AI is sentient. It's alive. It's alive. And I've seen a lot of podcasts recently that kind of like suggest that, oh yeah, we're this is an ex Google person, and this means that it's alive. And I don't know, like any person that's an ex Google person like might have some ulterior motive to say, oh, it's alive, there's the apocalypse is coming, all this kind of things. But I'm relatively optimistic about human beings being able to integrate AI into our lives. So hopefully this doesn't age poorly. Anyway, so general intelligence, which is a machine with artificial general intelligence, should be able to solve a wide variety of problems with a breadth and versatility similar to human intelligence. So techniques. AI research uses a wide variety of techniques to accomplish the goals above. So you've got search and optimization. AI can solve many problems by intelligently searching through many possible solutions. There are two variety of kinds of search used in AI: space search, and local search. So state space search searches through a tree of possible states to try and find a goal state. For example, planning algorithms to search through trees of goals and sub-goals, attempting to find a goal, finding a path to a target goal, and process called means ends analysis.